Okay, this will be our last lecture on SQL, and at this point we are continuing our discussion of the data manipulation language in SQL, and more specifically we have been concentrating for the last couple of lectures on retrieval. So the portion of the commands in the data manipulation language associated with retrieval, and it's mentioned that the command that allows us to do retrieval in SQL is select, and it has several options, variations to it, and we are gradually, progressively studying more and more of those options. So in today's last lecture about SQL, the concept that we will be introducing is the concept of aggregation. We'll see with the help of example what we mean by aggregation, what does aggregation involve during the retrieval process, and the two commands, rather the two clauses in the select command that are associated with aggregation are the GroupBy clause and the having clause. So just for reference, here is the grand scheme of things. This is the grand scheme of what the select command looks like. These are all the different clauses. So if you think of the select command as a whole, so if you think of this entire command, you can think of the command as consisting of a bunch of clauses. Okay, just like you have legal documents which have clause number 1, clause number 2, clause number 3, and so forth. So you can think of the select statement overall as consisting of a bunch of clauses. And out of those, we have the select clause, the from clause, the where clause, and these are the three clauses that we have discussed so far. And in today's lecture, we will spend most of our time on these two, the GroupBy and the having clause, because they are associated with the concept of aggregation during the retrieval process. Then at the end, we'll spend a couple of minutes on the order by clause. As you might guess, that clause, all it does is it sorts columns by a certain order, so it's really nothing complicated to it. So we'll just leave a few minutes at the end to discuss that. But our major focus for this lecture is on these two clauses, the GroupBy clause and the having clause. And these two clauses are associated with the concept of aggregation. Okay, so let's spend a few minutes to understand what aggregation will be. Now, just as a reminder, the order in which we write this SQL command, this is the order in which we write the clauses in the SQL command, in the select command rather. But when it comes to executing them internally, once you feed this command in, internally what is the order in which the execution gets done. Up to now, we know that from where these two, the from is executed first, what are the tables from which information is executed, okay? The where clause is executed next because it identifies what are the rows that need to be extracted. So that we know, we have already covered these in this sequence. Now the GroupBy and the having, they are executed after the where is executed. So remember this sequence. I think it helps you remember the sequence because it helps you make sense of the output. So when you write a select statement that has the from clause, the where clause, the GroupBy clause, and the having clause, remembering the order in which the execution is done helps you understand the output. Why is the output the way it is? Okay? It helps you anticipate the output and also to understand the output once it comes out. So just to repeat, even though we write the select command, the clauses in a particular order that you see over here, when it comes to execution, the from clause is executed first because I first need to know what tables to get the information from. Then the where clause is executed because then I know what rows to take out. And after that, if they exist, if those clauses are there in the select command, the GroupBy and the having are executed. And at the very end, we do select. Select clause pulls out certain columns from the result. So the select clause is executed last. That we know from our previous example. What we are doing now is these two clauses, GroupBy and having, that are associated with the aggregation concept. Those are inserted there. That's the order in which they're executed is before the select. So from is done first, where is done next, group by is done next, having is done next, and at the very end we do select. So this is the sequence in which the clauses get executed. Let's keep that in mind as we proceed to look at some examples and then look at the grammar for how these clauses are actually expressed. Okay. So let's fill in some details now. As I mentioned a few minutes ago, the order by clause just sorts the output. So I'm just sort of pushing it off to the end and just spending a couple of minutes on it. I'll not spend any time on it until we get to the end. So here are the clauses that we mentioned in the preceding few minutes. What follows these clauses? That is, after you write each clause, after you write select, after you write from, what follows them, what you need to specify. So after the select clause, you specify in the select clause, you specify the columns that must show up in the output. The from clause lists the tables from which you need to get results. And if there's more than one table, then you need to specify the join, because you need to connect the tables in order to get the information that you need. The end result of the from, after the from is executed, the end result is always one table. Okay, that one table could be the result of joins, or it could be the result of one table that actually exists in the database. But in any case, the output from after executing the from clause is one table. Next, the where clause is executed, and what do we specify with the where clause? We specify the conditions, qualifying conditions for a record. Remember those expressions that we talked about, the logical expression. So based on whether that expression is true or false, a record is either included in the output or not included in the output. Okay, so that's what happens from these with these three clauses. And this is what we specify. Group by, the group by clause. What follows the group by clause? After you write group by, you list the columns that will be used for grouping, and having specifies the conditions for including groups. Okay, so some of these details may not make sense right now until we actually see an example, but I just want you to have a high-level sense of what is the grammar that is going to follow. When we actually get into the examples, you will see what each of these details looks like. All right. Now let me use this vendor database that we've been using for many of the lectures, just to give you some sense of example queries to lead into our discussion of the syntax. So the concept that we're about to discuss is the concept of aggregation, and the way that is implemented in the SQL command select is through two clauses. One is the group by clause and the other is the having clause. We'll see those examples of those specific clauses in just a minute. But let me give you an example of a query that would require aggregation. Okay, so let's say, just look at this invoice table. This table contains a list of invoices, invoice number 1 all the way to invoice number 8. Now, if you probe a little bit, notice one thing. There are two invoices for customer 1011. So here is one invoice from customer 1011. Here is a second invoice from customer 1011. Here's a third invoice for customer 1011. Okay. Similarly, there are two invoices for customer 10014. Here is one invoice for customer 10014. Here is another invoice for customer 10014. Okay, so there are multiple invoices for certain customers. All right. Now, suppose I want to know, as the owner of the store, suppose I want to know the dollar value, the total dollar value of all the outstanding invoices for each customer. So it's like at the end of the month, I want to know what amounts are outstanding to me. So for each customer, I want to know in total how much money do they owe me. Okay. Now, conceptually, what do I need to do in order to do that computation? So here, I have customer 10. There are three invoices for customer 1011, right? Here's the first one. Here's the second one. Here's the third one. So I need to find out the dollar value for each of these invoices. So I need to group these three records, isn't it? I need to create one group which contains the three records, and I need to add up the dollar amounts for those three. Okay. So typically, grouping is associated with aggregation That's why it's associated with aggregation operation. So this is an example of an aggregation. What have I just aggregated? I have aggregated the 3 invoices for customer 1011. So now if you extend this logic to all, let's say in this invoice table, let's say there are 1000 invoices, okay, and there are 10 customers. So these 10 customers, they have lots of invoices outstanding. When I group by customer, when I group the invoice table by customer, what I'm saying is take all the invoices for one customer and put them in one group. So first customer, what are all the invoices for the first customer? Second customer, what are all the invoices for the second customer? So I'm basically taking this table and I'm grouping it. I'm grouping it, meaning grouping all the records by customer. So physically, you can think of it as a sorting operation. So I would take this table and sort it by customer code. If I sort this table by customer code, all the invoices for each customer will form a group, isn't it? One right next to each other. And then once I have the group, I can do my aggregation. For instance, I can find the total dollar amount owed to me by each customer. I can find the average dollar amount owed to me by each customer. I can find the maximum dollar amount of the invoices owed to me by any of the customers. So the aggregation operations differ, but I hope you're getting a sense of what aggregation entails. Another example from an educational setting. So, like in our business school, we have 5 different majors, right? We have marketing majors, let's say management majors, accounting majors, finance majors, and ISOM majors. Okay. Suppose the dean wants to know, have a comparative assessment of how students are performing in the different majors. So I have, let's say, just visualize, I have one table which has a whole list of students. Let's say there are 5,000 students in the business school. So I have a list of 5,000 students, and for each student, I have their GPA. All right. And the dean wants to know which department or which area the students are performing better than others. So what I would conceptually need to do is take these 5,000 students, these 5,000 records, and group them by department. So all the students in finance would be one group. All the students in accounting would form one group. So I would instruct SQL, please group these 5,000 records by major. So all the students in one major would form one group. And then once I have the group, I can ask SQL, please compute the average GPA for all the students in each group. So then what SQL would do, it would look at all the students in the accounting group, compute that average GPA. Okay, it look at all the students in the marketing group, and it would compute the average GPA for all the marketing students. All right. So typically, once you do grouping, you follow that or you associate that with some kind of aggregation operation. So I hope you have a high-level view of what aggregation entails, what is actually being done. Then we'll look at the grammar of how you tell the database, please do such and such an aggregation. Okay, so we'll get into the nitty-gritties in just a moment. Okay, so just to repeat, to summarize the aggregation operation, the way you specify the aggregation, that is in the select statement, the group by clause is what is used to tell the software that this is the type of aggregation I want. So to continue with the example that I had, if I have a table of 5,000 undergrad students and each student belongs to a particular department, and I would tell the software group by department. So let's say I have a column in the student table called department. So here's a table called student, and there are 5,000 students. One of the columns is department. Okay, so there are 5,000 records. Each student is in a certain department. So if I tell SQL, if I tell the SQL Server, the database management system, group by department, then it would take those 5,000 records and put all the students in one department right next to one another. So they would have 5 different groups. First group would be the accounting department, second group might be marketing department, and so forth. Okay, so the way you tell the software that I want groups to be done, you must tell the software, you must tell SQL what is the attribute, what is the column by which grouping must be done. Okay, so the example that we discussed prior to the student example, I wanted to know the total dollar amount owed to me by my different customers. In that case, here is, I would tell SQL, please group the invoice table by customer code. So all the records belonging to the same customer would be right next to one another in one group. Okay, so to identify groups, I have to tell the SQL, I have to tell SQL what is the column by which the grouping should be done. Now, you can specify more than one column by which the grouping should be done, in which case those 2 or 3 columns are taken together. Okay. For instance, if the dean were to refine the request, instead of the dean saying, how are my undergraduate students doing by major, instead of saying, how are accounting students doing relative to marketing students, relative to finance students, suppose the dean says, how are accounting seniors performing relative to finance seniors? So then now you have 2 columns. You have the department and you have the year of the student, whether they're juniors, sophomores, freshmen, or seniors. In that case, I would say group by department and year. Okay, then the grouping would be done both by the department of the student as well as the year, the 2 together, the 2 columns together. Okay, so in any case, the grouping, in order for SQL to know how to do the grouping, you have to tell it which columns to group by. Okay, and as we mentioned right at the beginning of our discussion today, in terms of the order in which the group by clause is executed, it is executed after the where clause is executed. Okay, now once you have your group, then you can perform your aggregates. Okay, so what aggregation does is it takes all the records in one group and it collapses them into one group. For instance, if I had, out of those 5,000 students, if I had, let's say, 100 students in accounting, there are 100 accounting students, then once I group them by department, I would have 500 accounting students together. So I would have 500 records together right next to one another of accounting. And then I can compute the average GPA for those 500 students, okay? And that would immediately collapse those 500 records into one record, which contains the average GPA of those 500 accounting students. So the aggregation operation is done after the grouping, and there are different kinds of aggregation operations: minimum, maximum, average, and so forth. Okay, but the aggregation operation actually collapses the multiple records into a single result. That's conceptually what happens. Now let's proceed with this discussion and see some specific details. So this picture, I think it shows, we saw a picture like this before in the previous lecture, but we are using this, we are sort of enhancing this picture just to reinforce to us what is the sequence in which things happen. So the from clause, the select statement is written in a certain order, but executed in a different, an order that's different from the order in which it is written. So the first clause that's executed is the from clause. We know that by now. So the input to the from clause is one or more tables. So if there's more than one table, some kind of join will need to be performed. And the end result of the from clause, after executing the from clause, is one table, always one table. Okay. Taking this one table, we apply the where condition that pulls out a bunch of rows from that one table. Okay. Once I have those rows pulled out from the table, okay, then I can group by. If there is a group by clause, then I can sort them into groups. So whatever columns are specified, I take that one column and I group all the records by that column that is specified. Okay. Once that's done, then I can do my aggregation operation, whatever aggregation that needs to be done. And then as the very last step, I select the column. So the column selection is always the last step in the execution of the select statement. All right. So please take a few minutes and think through. So you might want to go back and look at this. This is the order in which we write the select statement, and this is the order in which they're executed. So to visualize what an output might look like, it helps to keep this picture in mind. So later on, when we we look at actual examples and look at the output, we'll say, aha, this is why the output is the way it is. Okay. So let's start with the simple example of a select statement excuse me, that has a group by clause. We'll see how it's written and look at the output, try to understand the output. Why is the output the way it is? Now, this particular command doesn't really have any aggregation operation yet. We will build up to that. We'll just go a little bit, little steps at a time. So here is the select statement. We have select E dot department ID. By now you know this E is an alias for employee. So you have select E dot department ID. So that's the column. This is the column that I want from the table E. And here's a group by. So notice the syntax for the group by. You say group by, and then you follow that with a list of the column or columns that will be used to group. Okay. So in words, what this statement is telling SQL is please take this table. Okay. And so the first clause that's executed is the from clause. We know that by now. So the from clause says pick the table E. So there's one table E that is being picked. The next clause that would have been executed had it been there would be the where clause. There is no where clause in this statement. So when there is no where clause, it means we are talking about the entire table, all the rows in the table. All right. So at this point, I know that I'm looking at all the rows in the employee table. Then it says group by employee by department ID. That's the group column. So now what SQL does is it takes all these records and it puts all the records with the same value of department ID together. So it groups the records by department ID. So just imagine visually, you would have this first record, second record, and then this one and this one. They'll be stuck next to each other, let's say as the first four records. Then the remaining records would be all the employees whose department ID is 501. So just for conceptual purposes, think of all these records being sorted by department ID. As soon as you sort them by department ID, all the employees with the same department ID come together in one group. Okay. And then it says select department ID. After the sorting is done, if I select the department ID, there are only two departments, distinct departments in that column, isn't it? It's 500, 501. Okay. So these are the two groups that are there. Okay. Now notice I have not done any kind of aggregation yet. For instance, I haven't said, please tell me the average salary for each department. So we'll build up to that. But at the moment, I'm just trying to explain to you what the grouping operation would do. It would take all the records in one group together, and some grouping, you must specify the column by which the grouping is done. Okay. As a matter of fact, this particular command, the select statement that we have, would be quite equivalent to this one. If I've written select distinct. If you go back to maybe a couple of lectures back, you will see what distinct that distinct qualifier produces. If I said select distinct E dot department ID from employee E, okay, and there's no where clause. If I just said this, then I would get exactly the same output as over here. Okay, so basically the group by clause instructs SQL to take all the records and identify them into groups based on the columns that are specified. So in this case, the end result is these two rows, 500, 501. Why is there one column? Because the select clause had only one column in it. So this is a very simple example of group by, grouping, the result of grouping. Okay, we still haven't done any aggregation operation yet, but we have grouped. Okay. Now here's a similar select statement. grouping. So it says select e.city. This time I'm instructing SQL, please pick this particular column. In the previous query, we had extracted the department ID column. Now we are saying, please extract the city column, e.city from employee, which is the employee table. There is no where clause. A where clause, remember, picks out specific rows. Since there is no where clause, I know that I'm dealing with all the rows in the table, all of these rows. And then I say group by e-city. So similar to the discussion that we had a few minutes back, just visually imagine that all the records are sorted by city. They're sorted by city. Okay. And then from that, so it would naturally form, the record would group themselves by city. All the employees in the same city would be right next to one another, and that would allow me to identify what are the different groups that are there in this table. And the answer, the different groups that are there in the table is, we have a bunch of employees who are in Fairfax. We have, in this case, only one employee who's in Vienna. There are two employees in Bethesda, so there's another group, Bethesda, then there's Silver Spring and Baltimore. Okay. So these are the different distinct, once I sort, conceptually, if the records are sorted by city, I can immediately see what are the groups that are there. So these are the 5 groups in terms of city. These are the 5 city groups that are there. So I hope you see the importance of the column in the group by clause. So when you specify a column in the group by clause, that tells SQL how to form the group, on what basis should it identify the groups. Okay. Here's another example which is very similar to the previous, not the immediately previous one, the one before that. It's very similar to the employee, to the department ID being used for grouping. So here we are. It says select e.state. So I'm now picking this particular column from the employee table. There is no where clause, so I'm dealing with all the records in the table. Group by e-state. So I'm telling SQL, please find me all the different groups by state that are there in the record. So conceptually, you can think of all the records being sorted by state, and as soon as you do that, you can easily identify how many groups are there in terms of states. And so based on the data that we have here, you can see I have one group of employees in Virginia, I have one group of employees in Maryland, and I have one group of employees in Arkansas. Okay, I don't know what AR is, Arkansas, I think. So there's one group of employees in Arkansas. So there are 3 groups in this. Once I group these records by state, there are 3 groups. Okay. Now notice there is one difference just in the syntax over here. I don't know if you've noticed it or not, so let me point it out to you. So here was the previous example, e.department ID, e.department ID. This is the way in which, the syntax in which the columns have been specified. Now, let's come to this example that we have just been discussing. Do you notice any difference? This time, do you see that there are brackets, there are square brackets around the columns? Okay. Now, typically, you're allowed to put square brackets around column names, and it's usually a very safe thing to do. So, for instance, I could have put square brackets around, let me see, go back. I could have put square brackets around city in this particular select statement. But when is it, why do we have these brackets at all? Okay. Sometimes column names have spaces in them. So here, look at this column name. It says last name, but there is an underscore between last and name. So it's just one character string. Similarly, if you have first name over here, there's an underscore between first and name. So from a technical standpoint, it's one character string. Okay. Sometimes for aesthetic reasons, for reasons of comprehension, we write column names with gaps in them. For instance, I could have written this column as last name with no underscore. So there would be a space between last and name. Similarly here, I could have first space name. If you have columns that have spaces in their names, then think of what would happen when you write that column here. So let me just to show you what we're talking about here. Suppose I had written e dot E dot first name. So there's a space between first and name. Okay, the system will get confused. I mean, it might ask itself, is there a column called first and name is something else? Okay, or what are we referring to here? So as soon as you put a bracket around the full name, then SQL knows that the column is named first space name. So anytime you have spaces in the name in the names that you're referring to, it's a good idea to put brackets around it. Okay. Sometimes names have special characters on them. For instance, you could have a column whose name is tax percentage. Okay. In that case, also, so as not to confuse SQL, it's good to put brackets around the column name. So it's always a good practice to put brackets around column name, but it's a safe thing to do. But oftentimes it clutters up the picture. So a lot of time we don't use the bracket, and it's not necessary to do so. But there are situations where it is absolutely necessary to put those brackets. One of those, a very common situation where you need the brackets, is when there's a gap in the spaces in the column names. Okay. And then it is the same thing for table. So you would need the bracket. Once in a while, not very frequently, once in a while, a column is named as a reserved word. For instance, it's possible, I suppose, you could have a table somewhere in the database that has a column. The name of the column is group. Okay, so this is the name of the column in a table. Now, I know that group is also a reserved word, meaning it has a special meaning to SQL. Anytime SQL sees the word group, it says, aha, I have to aggregate. Okay? So that it doesn't get confused, if I have a column called group, then I would put brackets around the word group. And this is what would tell SQL, hey, I'm not referring to the reserved word, I'm referring to a column called group. So those are the circumstances in which the square brackets are absolutely must be used. At other times it's optional, just you may or may not use them. Okay. Okay, now let's move on to actually doing the aggregations. As I mentioned over the last few minutes, the examples that we have been looking at just showed you how the grouping actually works. We actually haven't performed an aggregation operation, so that's what we're about to look at next. So how does aggregation work? I mentioned examples to you. So we said, let's say for the example that we're using here, once I group the employees by state, what I might want to do is find out the average salary of employees in each state. So again, visually, what do you think would be done? If I have this, look at this first group. We have 3 employees in Fairfax. Once I have grouped all the employees who are in Fairfax, I can take their individual salaries and compute the average of those salaries. Okay, so that's an example of an aggregation operation. All right. So for any given column, we would specify, here are some of these common aggregation operations: finding minimum, maximum, average, standard deviation, and counting. So there are different functions that one can use to compute, to perform the aggregation, and we will see what some of those are. Here are some of the different functions that can be used for aggregation. These are for arithmetic value. I could compute the minimum of a group of value. I could compute the maximum, the sum, average, standard deviation. Those are aggregation functions that one can use when the column has arithmetic content in it. Okay. Another aggregation function that is used very frequently is the count function. It simply counts the number of records. Okay. So what would be an example of the use of the count function? So suppose I come over here and I ask myself, the question that I pose is, how many employees do I have in each state? So I would first group the table by state, okay? And then I would count how many records there are in each state. So once I have this grouping, I would say, okay, there's 1, 2, 3, 4 records in the group Virginia. There are 3 records in the group MD. So there are 3 employees in Maryland. And there's 1 record in the group AR. So there's one employee in the state Arkansas. Okay. So the counting is another aggregation function that's done. Okay. And then there's a variation of count called count distinct, which doesn't involve the duplicates. So it doesn't count the duplicates. We'll see, once you see an example, I think the difference between count and count distinct will become clear. Okay. So let's look at some specific examples of the GroupBy clause doing aggregation. So let's say I have, in all these cases, is a student table. So let me just draw as a sample student table over here. So I have a student table, and it has various attributes. Okay, so it would have a student ID number, I suppose, as the primary key, and then it has a bunch of other attributes: student's GPA, name, address, and so forth. Okay, so we'll use attributes as needed when we go through the examples. So let's look at the first example here. Let's say I want to know the total number of students in this table. How many students do I have in this table? It's a counting function, right? I'm not looking for the student's ID number, not their GPA, nothing. Just how many students are there. Physically, this simply means counting the number of records in the table. So look at how we specified. We say select. So you already know what star is a shorthand for. Star is a shorthand for all columns. You have seen that in the very first lecture on SQL. Okay. So you're saying select star. So just forget about the count function for a moment. Just imagine that this command said select star from student S. What would the output be? The output would be all the records in the table, isn't it? And then, so the group, in this case, for this first SQL statement here, the select statement, the group is the set of all records in the table. And then I aggregate. What is the aggregation that I'm doing? I'm saying count the number of records. Count star. Star is all the columns, okay? So I'm saying count. So SQL will go through and count how many records are there in the table. The output from this grouping, from this aggregation, is just one number. It will say there are 50 records in the table, 100 records in the table, 5,000 records in the table. So the aggregation has resulted in the collapsing. So let's say there are 500 records in the table. The aggregation has resulted in the collapsing of 500 records into one number. There are 500 records in the table. Okay. Now let's refine that query and say, find the number of students who live in Fairfax. All right. So conceptually, what needs to happen? I first need to extract students who live in Fairfax and then do the count. Okay. So here there is. Notice that in this first example that we had, we didn't use the GroupBy clause. Correct. So we'll get to that in just a moment. But recall I said just a minute ago that once we say select star from student, the group that is formed is the set of all records. Okay, so that's the entire group. And we have done that, and we've counted the number of records. Now let's look at the second example. Select count star from student S, where city, S.city equals Fairfax. So one of the attributes of student is the column city. Okay. Now, remember the order in which clauses get executed. First clause to be executed is the from clause. So SQL says, aha, I'm working with the student table. The next clause to be executed is the where clause. All right. So where says pull out only those rows for which the city is Fairfax. So the SQL goes to the entire table and pulls out only those students for which the value of city is Fairfax. So at the end of the where clause, I have all the records for students who live in Fairfax. Maybe there are 5 students, maybe there are 10 students, maybe there are 15 students. If there are 25 students who live in Fairfax, I would have 25 records at the end of executing where. Now, the last piece to be executed is select. So it says select count star. Count means count the number of records. So this select statement taken as a whole, its output would be the number of students who live in Fairfax. This is also a group, isn't it? Notice that we haven't used GroupBy here yet. We'll work our way to that. But this function, this select statement that I have written, is essentially identifying a group for me. It's identifying a group of students who live in Fairfax, and then we did an aggregation on it. So we did a count, okay, on it. Now here's a third example over here. So let's parse through. It says select minimum something, maximum something, average something from student S. All right. So let's parse them. The order in which clauses are executed. The first clause to be executed is the from clause. Okay. So SQL knows that I'm working with the student, the entire student table. How do I know it's working with the entire student table? There is no where clause. So the where clause pulls out specific rows. There is no where clause. So that tells me I'm working with all rows, all the rows in the table, the entire table. Okay. So from this entire table, there will be a column called GPA for the students, right? For each student, there will be a GPA. And what this select statement is saying is pick out that column, pick out that GPA column. So I'll just write it just for ease of discussion over here. So for every student, there would be a GPA. Okay. So now, since there is no where clause, so just in the previous example, we had a where clause. In this example, we don't have any where clause. That tells me my group, the group that I'm talking about, is all the rows, entire set of all students. Okay, that's the group. And now I'm going to aggregate that particular group. I have not used the word GroupBy yet. Okay, so my group is the set of all students. So I'm saying that in that group, out of that group, it's all students. Pick this one column, the GPA. This is the name of the column. Okay. And I'm computing 3 different aggregations. The first computation I'm doing is saying calculate the minimum GPA. So this would identify one or more students that have the lowest GPA in the class. The second one would identify this one or more students who have the highest GPA out of the set of in that group of all students. The last aggregation that I'm doing, I'm saying take all these students, this group of all students, and within that group, compute the average GPA. Now, by now you know that this keyword as is simply an alias, just so that the output is easy to comprehend. We are relabeling the name of this calculated column. This is a calculated value. I'm relabeling it as minimum GPA, maximum GPA, and average GPA. So once this select statement is executed, I think you can guess what the output will look like. The output from this select statement, it will have 3 columns. One column would be minimum GPA, that's this label. The second column would be maximum GPA, that's this name. And the last one would be average GPA, which is this one. And there would be 3 numbers. Okay. So the end result would have 1 row and 3 columns. So do you see how the group, in this case, the group is the set of all students, how that and all those records, the group has been collapsed into one set of values because of the aggregation operation that's been done here. So in this case, the aggregation that we did was one was a minimum, one was a maximum, one was the average. Okay. So with this, so we are using this select from where clauses because these are clauses that we have seen before. So these 3 operations, the 3 statements that you just saw are examples of aggregation. But we didn't use the GroupBy clause yet. Simply, and the reason I could do this is because in this case, in these all 3 examples, the group I shouldn't say all three examples, sorry, the first and the third example. In the first and the third example, the group was the set of all students. In the second example, I had one group. This was simply the group of students who live in Fairfax. So in each of these three examples, we had one group. In the first example, the group was the set of all students. In the second example, the group was the set of students who live in Fairfax. And in the third example, this was students or set of all students. Okay. In each of these three cases, there was only one group in play. But what these three examples showed you is once you have a group, how does the aggregation operation on the group work? Okay. So now we'll extend this to multiple groups, and that's where the use of the GroupBy clause will come in handy. Okay. So let's take a slightly more sophisticated example here. In the previous examples that we just discussed for the last 5 minutes or so, 5 or 10 minutes, we are always working with one group, and the idea there was to show you how the aggregation function works on one group. Okay. Now what you will see here is the same aggregation function being done, but now on multiple groups. So let's look at this SQL statement, parse its different clauses, and see what the output will look like. So here's the statement. So I want the average GPA of each major. So there's a bunch of students. I have a table here with a whole bunch of students, or a student record. And what I want to know, the dean wants to know, somebody wants to know, what is the average GPA of students in each major. So conceptually, I think you can imagine what you need to do. In the previous example, you had the average, you had something calculated for all the students who live in Fairfax, how many students live in Fairfax. So here, what I need to do is take all these student records and group them by major. Once I group them by major, then within each group, I can compute the aggregation. All right, so let's look at the syntax. Select S dot major. Okay, now notice the labeling of the column. We're saying select S dot major. So this first column is selected. For the moment, forget about the function average. Just imagine that that word is not there. Just imagine that the average function is not there. So then it would be S dot major, S dot GPA. So we are picking these two columns. So the select clause picked two columns, the major and GPA. So this column and this column. So now, this is the table, and you'll know that you're going to focus on those two columns alone. Right? From student S, group by S major. So let's go back to the order in which clauses are executed. The first clause to be executed is the from clause. That means SQL will look at this statement and say, aha, I'm working with this table S. Okay. Now, the next clause that would have been executed had it been there is the where clause, because it pulls out rows that you're going to work on. There is no where clause in this statement. As soon as you see that there's no where clause, it means you're working with all the rows. You haven't pulled out any specific row. You're working with all the rows in the table. So the absence of a where clause tells me that I'm working with all the rows in the table. Okay. So now I will group those rows by major. Since I have all the rows, as soon as I group them by major, what would happen? All the students who are in the same major would be put right next to one another as a group. So I would have one group with these two ISOM students. I would have one group with this one accounting student. I would have one group with these two finance students. And I would have one group with these two marketing students, and I would have another group with these two management students. So there are all these, five, I think, majors. So I would have those 5 groups. All right. And then within those 5 groups, each of those 5 groups, I would compute the average. So this average is computed separately for each of the majors. Okay. So notice that the column by which you are grouping, when you say group by S major, S dot major, so this is the column based on which you're doing your grouping. That grouping column must also show up in the select statement, select clause. It would be a grammatical mistake If you tell SQL, I want to group by major, but then the major itself doesn't show up, that column name doesn't show up in the select clause. That has to show up. And then you specify whatever averaging that you want. So what would the output look like over here? Let's just imagine. Let's just talk through what the output would look like. Get the pen over here. Okay, what would the output look like? First of all, there would be one row per group. Since we have group by major, if you think back to the previous examples that we just discussed over the last 10-15 minutes, you would have one row per group. So you would have, let's say, accounting as one group, marketing as one group, ISOM as another group, finance as another group, and management. So these are the 5 groups that show up in this column major. Okay, and in the second column, notice that we have an alias just for readability. So we are telling SQL, this computed column that you're getting, don't keep the heading as average SGPA, just make the heading AVG GPA. This is more readable. Okay, and hence you see the heading of the column as AVG GPA. So what is the value that will show up here? The value that will show up here for accounting is I have only one accounting student, so here the value that would show up would be 2.9. Okay, I don't see any other accounting student. Now let's think about what would happen for marketing. What's the value that would show up next to marketing? So I have one marketing student here and another marketing student here. I don't see any other marketing students. So there are 2 marketing students. The value that would show up here would be the average of 3.1 and 2.7. Okay, the value that shows up here next to ISOM is the average of 3.5 and 3.9. So you see that what the calculations that we saw for one group over here in the previous example, they are being done repeated for each group. All right. So similarly for management, you would see the average of 3.1 and 2.8. Those are the 2 management students. Those are the 2 students in the group called management. So I hope you get a sense of what aggregation consists of and how the group by clause, how you write the group by clause. It's very important, this matching of the matching of the column by which you're doing the grouping must appear in the select clause as well. So if that column doesn't show up in the select clause, then you will get a syntax error saying that the grouping cannot be done. Now, the grouping can be done by more than one column. The example that we used a little while back was when a dean, let's say, wants to know the average GPA of students by major and year. For instance, they want separately to know the average GPA of accounting seniors, of accounting juniors, of marketing seniors, and marketing juniors. All right. So if you have this multiple column grouping, then in the case of the dean's example that I just mentioned, the way you would have written the so to continue this example with our dean, so imagine that there was another column over here called year of the student. So it would say freshman, sophomore, freshman, junior, senior, freshman, and so forth. Suppose that there was another column over there. And the dean wants to know the average GPA by major and by year. In that case, I would need to say group by S dot major, comma, S dot year. So those 2 columns together would form the grouping. So you would have one group of ISOM seniors, you would have one group of ISOM juniors, you would have one group of finance seniors, one group of finance juniors. So both the columns together are being used to form the groups. And in that case, in the select clause, I would need to say s.major and s.year. So it's very important that the specifications match. Whatever you specify as the grouping column must also show up in the select clause prior to doing your aggregation. Okay, so this will be followed by whatever columns you are using to doing your aggregation. Continuing with the examples over here, so take the laser pointer. So I have select s.major, comma, count star as num students. As is just an alias for the column name, from student s, group by s major. Fine. So we'll go through the same routine. What is the order in which the statements, clauses are executed? First clause to be executed is the from clause. And here we're not doing anything fancy. We're just using a table that already exists in the database. So the database management system SQL Server says, oh, okay, I'm working with the table S. The next step is to pull out rows. And that would have been done with the where clause. We don't have a where clause. So that tells me that I'm working with all the records in this particular table. Okay. And then the next step is I do my grouping. So it says here, group by major. So from our previous discussion, you know that I would have 5 rows because there are 5 groups of majors. So as soon as I group all the students by major based on the data that is available here in this table, I have ISOM as a major, finance, accounting, and so forth. Okay, so I would have 5 rows, 1 for each of the majors. Once again, notice that whatever column or columns I'm using for grouping, they must also show up in the select clause. And then I have the aggregation. Star simply refers to all the columns, and counts the number of records. So basically, for each group, what this aggregation function will do is for each group, it will tell me how many records are there in that group. So for ISOM, it will tell me 2, that there are 2 records that correspond to ISOM. For finance, it will say there are 2 records. For accounting, it will say 1. And for management, it would say 1, 2. And for marketing, it would say 1, 2. There are 2 marketing students. Okay, so it would say 2. So this is what the output would look like. And here the title, the name of this column, num student, results from this alias. The as keyword is what tells me that the heading for the column, the alias for that heading, is num student. Okay. Another variation of the aggregation, another example rather. So same table. So I start from the from clause. I know that I'm working with the student table S. I'm grouping by major. So this is the column that I'm using for grouping. And as soon as that happens, based on the values that I see in this table, I know there are 5 groups. So there will be 5 rows in the output. 1, 2, 3, 4, 5. Okay. Why 3 columns in the output? Look at the select clause. The select clause lists the columns that needs to be shown in the output. So once again, notice that the column or columns used for grouping must show up in the select clause as well. So here's s.major. That's the first column. And then I have 2 other columns. These are calculated aggregations. This is where the aggregation happens. The first is count star. So it tells me what this is asking me the SQL to do is for each group, there are 5 groups, right? So for each group, tell me how many records are there in the group, count the number of records in the group, and tell me the average GPA. So look in the GPA column for each group and compute the average for each group. So let's say for ISOM, for number of students, it would say 2. That's the count. Here's one ISOM student, here's the second ISOM student, and the average GPA would be the average of 3.5 and 3.9. That's what would show up here. So for accounting, the number of students would show up as 1, since there's only one accounting student that's showing up, and the average GPA would show up as 2.9. Let's take finance. The number of students, so that for the group called finance, if you just think of the 2 rows that constitute finance, that's the group. The count, the number of students is 2. 1, 2. So this would show up as 2. And the average GPA would be the average of 3.6 and 3.7. So 3.65, that's what would show up. So I hope you're getting a sense of how grouping works in a table. And once you have the groups, how the aggregation functions work with the groups that have been identified as part of the execution of the command. Okay, so let's get back to the grammar of the overall select statement. I'm just tracing back to an earlier slide. Yeah, so we had mentioned at the beginning of today's lecture that we'll focus on group by and having, these 2 clauses that help with aggregation. Okay? So we've spent all our time so far on the group by clause. Now we want to spend a few minutes on the having clause, and it's fairly simple actually. It just pulls out certain rows. So this is what we are concentrating on now. Hopefully you've gotten a sense of how the group by clause works for aggregation. Now let's take a look at what having does. Okay. Then let me move back to the. Okay, so here's the having clause. So what does the having clause do? So it sets up a condition for selecting records produced after group by. So do you see it's executed after group by is completed. So let's come back to this example. So this table that you're seeing is the result of group by. Once group by is executed, this is the table that would be the result. Suppose I wanted to know all the majors whose average GPA is more than 2.5. So I want the names of the majors whose average GPA is 2.5. So what would need to happen? First thing I would need to do is compute the average GPA of all the majors. So I would have all the groups, and for each group, in this case I have group by major. So for each of the 5 groups, I would compute the average GPA. And then I would pull out those groups for which the average GPA is more than 2.5. So that's what having does. Having pulls out groups that meet a certain criteria. Okay, so it's like a where clause, but for groups. Okay, so you've already seen the where clause earlier, working with single table, but it's like it's similar to that, but for groups. Okay. So let's look at this SQL statement and then parse it. So we have select e.city from employee group by e.city having count. So everything is the same. All the different clauses are what we have seen up to now. We have a new clause here, which says having count greater than or equal to 2. Okay. So how does that work? First thing is, the having clause is executed after the group by clause. Okay, so first clause to be executed is from. Okay, and then we do the grouping. So it says group by city and select e-city. Okay. Okay, I just realized I need to put in. I need to complete the aggregation. I haven't written the aggregation here. So I should say e.city count star. That needs to be there. Okay. All right. So how do we parse this SQL command? So we are saying select e.city, comma count star from employee e group by e-city having count greater than or equal to 2. So we know that the first clause to be executed is the from clause, which means I'm working with the employee table. There is no where clause, meaning I'm working with all the records in the table. I'm not working with just a subset of records in the table. I'm working with all the records in the table. So then the next clause that's executed is GroupBy. So I take all these records in the table and I group them by city. So I put all the records in the same city. All the Fairfaxes come together, all the Viennas come together, all the Bethesdas come together, all the Silver Spring come together, and so forth. Okay. So let's think about what the result looks like just after group. So I haven't yet executed the having clause, but I've finished executing the GroupBy clause. Why are there two columns in the output? Because the select clause has these two. Once again, notice that the column that is used for grouping, which is city, must also show up in the select clause. So I have two columns. One is city and the other is count. So let's see what the output might look like. How many groups would I have? First of all, I have 1, Fairfax, Vienna, Bethesda, Silver Spring, Baltimore. So there's 1, 2, 3, 4, 5. So there are 5 cities. Okay. So let me just list them. Oops. So let's just write, we have Bethesda, we have Fairfax, we have Silver Spring, I'll just write SS, and then we have Baltimore and Vienna. I don't want to go too far down here. So I hope you see where these 5 rows come from. Those are the 5 groups that would be identified by this executing this grouping clause. Okay. Now, once I have those 5 groups, what I have told SQL is for each of the groups, count the number of records. The star is all column. So count function simply counts how many records there are in each group. So for Bethesda, for example, I have only 1 employee who's in Bethesda. So I put 1. For Fairfax, I will say 1, 2, 3. So there are 3 employees in Bethesda. So there are 3 employees in that group. Now look at Silver Spring, there's only 1 employee in that. For Baltimore, there is 1. And for Vienna, how many do I have? I have 1. Okay. So this is what the output looks like after the GroupBy. Then the having clause is applied after the GroupBy is finished. So the having says, pull out only those groups that meet this condition. This condition says count should be greater than or equal to 2. Okay. So, actually Bethesda has 2. Sorry. Bethesda has 2. Here's Bethesda, and there was another one. Here's Bethesda 2. Okay. So this condition says having count greater than or equal to 2. All right. So I will only pull out this group and this group. So only the groups that meet that particular condition are pulled out, and we would pick out the cities. Now, if I had this particular count star as it's written, then the output would also contain the count. It would say 2. Fairfax would be 3, and Bethesda would be 2. If I didn't have the count star in my list, then this second column would not be there. Only Fairfax and Bethesda would show up. So the answer would say only Fairfax and Bethesda are 2 cities that have 2 or more employees in that particular city. So I hope you've seen how the grouping function works. What do we mean by aggregation? And also the having clause, how does it operate after the grouping clause is finished, okay, is executed, all right? Now let's look at a slightly more complex involved example, but we'll follow the same logic and we will have the same string of sequence of operation, which clause gets executed first, which clause gets executed second, and so forth. So let's look at the select statement. It says select from where group by having. So all of these different clauses are there. So we know the order in which things get done. First, order of business. What's the table from which extraction is being done? So the from clause is what gets done first. And I know that I'm working with the table employee. This is the employee table. Now, unlike the 2 examples that we've been looking at for the last 10-15 minutes, Here we have a where clause. So if the where is done next, after the from, the where clause is executed next. We know that from our discussion at the beginning of today's lecture and for the previous two lectures. Okay, so we have a where clause that tells me I'm not working with all the records in the table, only some. And what are those some records? Salary must be greater than or equal to 60,000. So that immediately pulls out a subset of the records. Okay. Once I have done that, the next clause to be executed would be group. I would do the grouping based on just those records that I have extracted based on this criteria, and then I will apply the having clause. Okay. So here is the steps of the output, intermediate output that happened. So here we have identified this employee salary which we are working. The next clause that gets executed is where E.salary is greater than or equal to 60,000. As the result of that, certain employees fall out. So this employee falls out, the salary is less than 60,000. This employee falls out, this one, and this one. So what remains is 1, 2, 3, 4. So these are the 4 employees who remain. Their salaries is greater than 60,000. All right. So the where clause is executed next. So the sequence, you see the sequence in which the clauses get executed is very important. All right. So this is the intermediate result after the clause, where clause salary greater than or equal to 60,000 is executed. All right. Now we do our grouping. So this clause over here, now that the where clause has been executed, the next clause to be executed is group by. Group by each city. So we are grouping by city over here. Bethesda would be one group with 2 employees. Fairfax would be one group with 1 employee. Silver Spring would be one group with 1 employee. Okay, so the intermediate result over here, let's see, okay, if I can write it down. So the intermediate output over here, there would be three groups. One would be Fairfax, the other would be Bethesda, and the third would be Silver Spring. Okay, so the count for Fairfax would be 1. The count for Bethesda would be 2. So there are 2 records in the group Fairfax. I'm sorry, there's 1 record in the group Fairfax. There are 2 records in the group Bethesda, and there's 1 record in the group Silver Spring. All right. Next, we would apply the having clause. The having clause is after you've done grouping, pick out the groups that meet this particular condition. Okay. So the only group that meets this condition is Bethesda. It has 2 employees in it, so it meets the condition greater than or equal to 2. And then the last operation is select, and the select says please pick the city, pick that 1 column. So I picked the city from the output, and here is the output, just the name of the Bethesda. So Bethesda is the 1 city where we have 2 or more employees, and the salary is greater than 60,000. Okay, so this is the sequence of operations that results based on the select statement, the SQL statement that you see over here. And I hope you saw the effects of the order in which various clauses are executed. All right. So let's try and close out with a third example. So here we have a student table. We have the G number, first name, last name, the major of the student, and the GPA. And look at the select statement. It says select S.major average GPA, okay, from student group by having. All right. Notice that there is no where clause in this select statement. You know by now that when there is no where clause, it means you're not pulling out specific rows. You're working with all the rows in the table. So the first clause that gets executed is the from clause. In this case, it's trivial because all it's saying is I'm working with the table S, which is student. There is no where clause that would have been executed next, meaning I'm working with all the records in the table. The next clause to be executed is group. And we're saying group by major. So it would take all these records, and students who are with the same major will be put in different groups. So there'll be one group with these two ISOM students. There would be one group with just this one accounting student. There would be one group with these two finance students. And there would be one group with this management students over here. And then one group with these two marketing students. Okay, so there are 5 different groups. As before, let me point out the column that you're using for grouping must also show up in the select statement. Otherwise, it would be a problem. Okay, so let's see what are the intermediate results. So since I'm working with all the records in the table, let's look at the output from the GroupBy. So from the GroupBy, I would have 5 rows. I'm not drawing all 5 because I'll run out of space. So I would have 5 rows, and each one row corresponding to each major. So ISOM, marketing, accounting, and so forth. And for each of these majors, I would have the average GPA. We've seen this in one or more examples before. Then we apply the having clause. Having clause, average GPA greater than or equal to 3.0. So I don't know what these average GPAs would be. So let's just, for sake of discussion, say that the marketing major is the only one that has average GPA greater than or equal to 3. In that case, there would be only one row in this intermediate output. It would say marketing, and let's say the average GPA is 3.2. Just for discussion, I don't know what it is actually. And so for marketing is 3.2. And then the select operation would apply. So the select operation says, please list the major as well as the average GPA and give this particular alias. So the result would have 2 columns. One column would say major. The heading for the other column would be AVG GPA. That's the alias. And here it would say marketing and 3.2. That's what the output would look like. Okay, so that's the result after applying the select. The select clause is what gets done last. That picks out the columns that you want to show. Now, as I mentioned at the beginning of this lecture, I just spent a couple of minutes on the order by clause. All that the order by clause does is it sorts the output based on the columns that you specify. Now, so for instance, if over here I had written over here order by S dot major, and if there were more than one major in the output, it would simply list them alphabetically. So all that order does is it sorts the output, and it's done very absolutely at the end. So once you have the final table, all that order by does, it says, once you tell it what columns to sort things by, it takes the final output and it sorts it by that one or more columns that you specify. Okay, so this is what the order by column clause does. Okay, so this final lesson on SQL, what have we done? We basically looked at the aggregation function. How do you do aggregation? We saw various examples of actual real-life queries where you need to do aggregation. Basically, in aggregation, you're forming groups and you're computing some kind of collective summary operation on it. So some of the common aggregations that you do is you sum values, you take averages of values, minimum, maximum, you count the number of values. So these are different types of aggregation functions that are done, and the clause in SQL that allows you to do aggregation is the GroupBy. Okay, so GroupBy and having, they're sort of cousins. GroupBy actually does the aggregation and the grouping based on which you can do your aggregation, and all that the having clause does is it pulls out groups that meet a certain condition. Okay, so with that we wrap up our discussion of our lessons on SQL.